Here we look at the derangement counting problem again, but now we're looking at derangements of 1, 2, 3, 4, 5. So total number of permutations of 1, 2, 3, 4, 5 is 5 factorial, which is 120. And so this grid up here shows all 120 possible permutations of 1, 2, 3, 4, 5. And the annotation is the same as in the previous video. So the ones that send 1 to 1, these are the top two rows here, where the 1 has got a blue blob around it. The ones that send 2 to 2, we've got some of them up here, and then some more over here. These are the ones where the 2 is marked with a green background. And then we've got the ones where the 3 is marked with an orange background. Those are the ones where 3 appears in the third position. So we're looking at a permutation that sends 3 to itself, and so on. And so we want to count the total number of derangements. And again, we can do this using the inclusion-exclusion principle. So that says that the size of D, so D is the complement in the set P of all permutations of the union of the sets Pi, where P little I is the collection of permutations that send I to itself. So if we have some set capital I, a subset of 1, 2, 3, 4, 5 of size K, okay, then P subscript capital I, that's the set of permutations that send everything in I to itself. Okay, so then there's 5 so if I has size K, there's 5 minus K numbers outside I, and then for a permutation in P capital I, we can permute those 5 minus K things in any way that we want. So there's 5 minus K factorial ways to do that. Okay, so the so the size of the set P sub P capital I is 5 minus K factorial. Okay, and if we add that up over all possible sets I of size K, well, there's 5 choose K subsets of that type. Okay, so we have to take this 5 choose K and then multiply by the 5 minus K factorial. And of course 5 choose K is 5 factorial over K factorial, 5 minus K factorial, so the 5 minus K factorials are cancelling out, and what we get is 5 factorial over K factorial. That's the sum of all these, the sizes of all the sets Pi where I has size K. Okay. The inclusion-exclusion principle says that we have to take this and multiply it by minus 1 to the K, and then take the sum over K, and that's going to be the number of derangements. Okay, so we get the sum over K of minus 1 to the K times this number 5 over K 5 factorial over K factorial. And if we want, we can take out the factor of 5 factorial, and then inside the brackets we get the sum minus 1 to the K over K factorial. So 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial. Notice incidentally that the 0 factorial and 1 factorial are both equal to 1, so these first two terms are going to cancel each other out, and then we've got all these other terms here. Yeah, and in this particular case with n equals 5, so we get 120 minus 120 plus 60 minus 20 plus 5 minus 1 ends up being 44. And if you look carefully at this grid here, you count all the grey squares, you'll find that there's 44 of them.